Hello, my name is Syed Ali Adnan and today I will be explaining the concept of power factor in AC circuits. Power factor is an important concept in electrical system because it tells us how efficiently the power is being used in a circuit. With that being said, let's begin. Power factor is a measure of how efficiently electric power is used in an AC circuit. It is defined as the ratio of real power to apparent power. Real power is the useful power that performs actual work, such as running motors or lighting bulbs. Apparent power is the total power supplied by the source. Mathematically, power factor is given by P divided by S, where P represents real power in watts and S represents apparent power in volt amperes. The value of power factor ranges between 0 to 1, where a value closer to 1 indicates better efficiency. Let's talk about phase difference now. In AC circuits, voltage and currents are sinusoidal signals. In circuits that contain inductor or capacitors, the voltage and current do not reach their maximum values at the same time. This creates a phase difference between them. The phase difference is represented by the angle phi. The power factor is equal to the cosine of this phase angle. When the phase angle increases, the power factor decreases, which means the circuit becomes less efficient. There are three main types of power factor. The first is unity power factor, where voltage and current are perfectly in phase and the power factor is equal to 1. The second type is lagging power factor. This occurs in inductive circuits, such as circuits containing motors or transformers where the current lags behind the voltage. The third type is leading power factor. This occurs in capacitive circuits where the current leads the voltage. Power factor can be also explained using the power triangle. The power triangle shows the relationship between real power, reactive power, and apparent power. Real power represents the useful power that performs work and is measured in watts. Reactive power represents the power that is stored and returned by the inductors and capacitors, and it is measured in VAR. Apparent power is the total power supplied to the circuit and is measured in volt amperes. These quantities are related using the S squared equals P squared plus Q squared. As I mentioned earlier, power factor is important in electric system because a low power factor causes inefficiencies in electric systems. When power factor is low, more current is required to deliver the same amount of useful power. This leads to high energy losses, overheating of electric equipment, and reduced system efficiency. For this reason, many electric systems use capacitors to improve the power factor and increase efficiency. In conclusion, power factor is an important concept in AC circuit that indicates how efficiently electric power is used. It depends on the phase difference between voltage and current and can be expressed as the cosine of the phase angle. Maintaining a high power factor improves system efficiency and reduces energy losses in electric system.